Alrighty, let's get started. Hey, class. Hope you guys are having a good week. This is about spring break for you guys, and spring break is going well. Let's go ahead and go over this lab six that we have, and go over some of the some things that you might want to look into when doing regression diagnostics. There are a few things that you guys went over in lecture that I would admonish you guys to go back over for from over that are key pieces to the regression to answering some of the questions. For instance, let's go back to one of the lectures that you guys, when you started looking at regression, you started to get the understanding of some of the key assumptions. That's one of the big things that you guys want to really particularly have in your particular document. You'll see that it state what are the assumptions that we need to look at with first analyze when we're looking at using this multiple regression. So let's go back to that and see that there are the key assumptions that we'll have to check and look at in this lab are here, found in the first part of the multiple regression, linear regression lecture. We want to look at linearity. We want to look at linearity. We want to look at homoscedasticity, normality, and the independence. So we're going to take that and I'm going to sit here and copy this and put this over here in our document. This is, well, let's not do that. Let's just take that instance. We first want to look at linearity. Then our next one will be homoscedasticity. And then we have normality assumptions that we need to check. And lastly, our independence. So we're going to look at all of these key things, and there are going to be some the methods that we want to assess, and also talk about our findings. So the methods that we will use to assess each one of these four assumptions. So let's go ahead and bring in our data. Go onto SAS and bring in our data. We're going to work with this scenic data set. And the one thing that we want to do first, we want to see what is in our data. Well, first, let's check our log, make sure our data is there. We have 113 observations and 5 variables. Now let's see what variables actually are in this particular data set. We have facilities, nurses, the prob of and that's our probability of infection. Then we have the rate of culture, and then we have our length of stay variable. So this is what we're going to do. We're going to look at these variables, and we're going to run a proc univariate. Let's run a proc univariate on these particular variables. I have it already created for you guys. I'm going to post this also so it can help you walk through some of the key diagnostics that you want to look at. So first we want to look at our linearity assumptions, and that key piece will help us look at just simple scatter plots. We really want to see the simple scatter plots and really see if it's moderately strong, but that's going to be in our we're going to look at a procedure called PROC-core. But at the beginning, we want to look at looking at each individual variable to see if there are any outliers. Make sure that each variable looks normally distributed, and that's what we look at, and we see is fairly distributed. There's nothing much that we need to worry about with these variables, and that gives us our first particular piece of this of this analysis. So let's go ahead and this proc univariate allows us to check and make sure our data is pretty clean, and also looks at the distribution of those key variables. So let's go ahead and look at a proc core, look at the correlations of these things. So you can just copy and paste and use proc core. It's a similar pieces of proc core that you see in proc univariate. But what we're going to do is we're going to take that plot and we're going to do plots equal to matrix. Plots equal to matrix. And let's look at what we're given in this proc core. So one of the things that we're given in the proc core is what we'll see is checking one of the assumptions. And proc core allows us to see that, you know, the first row shows pretty obvious linear associations with all the different variables. And what we're wanting to focus on is here, this probability of infection. That's the biggest one that we want to look at, because that's our main variable, looking at it versus each particular predictor. And this is how you will use this particular row to show us the associations. And it looks pretty clear that this is obviously a linear association. So that's good. That is what we actually needed to know by looking at the scatter plots. Now we see that the scatter plots we have done. Now we can go back over here, and one of the methods that we can think about is scatter plots, or simple scatter plots. Scatter. But there's also another part of the scatter plot. So now we actually just need to just type up our findings from that scatter plot. So we basically say that it is a linear associations with each predictor. That's all is necessary. Then our next one that we need to check is to check the linearity assumption is a proc, just to go into our regression. So let's copy and paste this again, and proc reg. And what we're going to do is we're going to use our model statement. So this equal to all our different predictors. But one thing that you'll remember if you go back to the lecture, the most recent lecture that the Professor Nazar had went over, is you'll see that we add in a statement in the called partial. Let's see, why is this not showing up? It should say, well, let's see if this runs. It should run, but I think I get my error. Oh, I said proc rec, or instead of reg. Let's go to reg. All right. Save that. I'm going to post this code again. Now let's see, look at our partial plots. Now we see that we're given a lot of different outputs for proc reg. Now, the main part that we want to go to is we want to look at our partial plots. And our partial plots are here. Now, what we see in our partial plots is that the PROC-reg is going to show us the linear association between each particular predictor in our main outcome. And you'll see that there is a linear association everywhere, but in the facilities and in the nurses, it looks to be not so much of a linear association, whereas the other two variables show pretty strong linear association. So these two particular, the facility and nurses, you'll see that there is not there is an insignificant amount of it is insignificant in our regression model, our multiple regression. And what you'll also, if you go and you'll look at your p-values, you'll see that it's corresponding that in the model as well. So now we've checked. Now we've checked the partial plots. So now our partial, what we'll say is that, what did you find? What did you find in the partial plot? So what we found was our plots showed that our prob of infection, prob of infection, you might want to say probability of infection, showed a linear association with two variables had a linear association with our cult variable. I think it's called, let's go back to that. So it was our rate of culture and also our length of stay variable. So our rate of culture and length of stay. But no association with the other two predictors. Now that is good. But now let's look at the scatter plot. I mean, not the scatter plot, but the residual plot. That is also found in our regression output. So we see it here. If you go back to the lecture, you'll see him, Dr. Nazar, going over where it is. So it's found here, and it looks to be that this is a random scatter. You don't see any pattern going on. So you're really fine. There's nothing else going on here. So you're really good to say that. What would we say? There looks to be no pattern with no violation, no major violation of linearity. Now that ends our linearity. Let's go quickly through the remaining of those. So heteroscedasticity, you're going to use your residual plots again. So that is the method of assessment here. And what we'll find through that, what we'll find is that it appears that there is no random scatter in our beginning. So it appears there's no random scatter here in our homoscedasticity. So there is no pattern consistent with that. So more specifically, our patterns that the pattern would have suggested that there is unequal variances are not present. So this is basically showing us that there is no pattern that we need to worry about. So that is all you need to put here. You can basically say the same thing that you said for linearity. And that's all. That's all you really need to think about. You can basically say the same thing. Now, what about normality? Normality, we look at this histogram. Let's go to the histogram. So we basically can look at this here to check our normality. And it looks that it's bell-shaped and we're fine. So all you need to know is we looked at our normality here and we checked the normality of each individual particular variable as well before when we did our proc univariate. And it looks like it's bell-shaped and there's evidence that there is no lack of normality. So that's all you have to say is, well, we looked at our histogram of normality. Histogram of residuals. And findings that it was bell-shaped. Bell-shaped gives us evidence that there is no gross lack of normality. Okay. So this is supposed to go over here to the findings. So we're fine. And then again, we can look at the normal quantile plot of residuals and see if there is any evidence. So our normal quantile plot, we'll see it here. And we don't see anything. So what we say again is doing the normal quantile plot. To assess our normality. Our finding is it has a linear pattern. and no major violations of normality. And lastly, we will go to our study design. And that, I mean, our independence. And that basically, we just look at the study design. And since our hospitals were randomly sampled, this would imply that the probability of infections will be unrelated. So that's what we have to remember. So independence is basically randomly sampling our finding All right, so with using random selection, random sampling of our particular hospitals, randomly sampling the hospitals, we see that this is the probabilities of infections are basically unrelated at each hospital. So let's go and make sure we've gotten everything. So the other thing that you would want to do is you would just go and copy and paste these particular plots that we use. The main plot we want to copy and paste here. Again, you can go over here, copy this plot over to this. That's well, that won't work. But screenshot or copy and paste each one of these plots. You want to look at your residuals, your normality of the residuals. You looked at the QQ plot. What else did we look at? We looked at our histogram, and so that will be what, and then our partial plots. So our partial plots, this plot, you can screenshot it and put it in your document to help show the output and what you found. And if you have any further questions, please send us an email and we will be happy to answer those questions or see us in our office hours. You guys have a good rest of your break, and the lecture will be due, or this lab will be due again by Thursday. So thank you guys.